Welcome to this demonstration of Parasoft Selenic, your Selenium bot that works while you sleep so you can have a better morning. In this video, I'm going to demonstrate how Parasoft Selenic significantly reduces the complexity associated with Selenium test maintenance and creation. For this demonstration, I'm going to assume the role of a Selenium test automation engineer. I have created a suite of Selenium tests for my organization in Java using the JUnit 4 format. In this particular test, I am validating one of the critical user stories of our banking application. And in this test, I have used something called the page object model, which we'll talk about more later. Now, it's somewhat frustrating for me, and I waste a lot of time when this test breaks due to the application changing. It is difficult for me to be able to differentiate between a real defect or regression in the application and a broken test. So to that end, I'm going to be going through an exercise where I'm going to be validating the current version of the application with this test and seeing what happens when I run the test against the next version of the application. So here I am inside of my IDE, Eclipse. I have a run configuration for executing my Selenium test, and I've set an argument to point the test to a location where my application is currently hosted. I'm going to go ahead and run this. So what's happening right now is that I'm running the current version of my Selenium test against the current version of my application. I'm essentially doing a sanity check just to make sure everything works. Okay, there are two tests that will execute. The first one was successful, and here goes the second one. Okay, it's also successful. So what that means to me is that my Selenium test works against the current version of my application. Now here's the challenge. Development has informed me that a new version of the application is available, and there's been some minor changes to it. But you know that a minor change can have a major impact. I've actually hosted both versions, just on different ports. So I'm going to go ahead and just log in here to see if I can quickly identify what might be different or what might have changed between these versions. This is a preemptive measure to try and understand the impact of the change. Okay, I see that the data has changed a little bit, but it's not immediately clear to me what's different. So what I'm going to do is run my existing Selenium test against the new version to see how it performs. So to do that, I'm simply going to change my run configuration to point to the new version of the application, and I'm also going to activate Parasoft Selenic. So here is Parasoft Selenic. And as you can see, there's an interactive UI in the run configuration where I can tell Selenic to do different things while my Selenium tests execute. In this case, I'm telling Selenic to watch this execution, and if anything were to fail, help me understand why it failed and how to recover. So now I'm going to run that Selenium test against the new version of the application and see what happens. Okay, so the accounts test is running. All right, looks like no regressions. Everything is going good. Okay, here comes the bill pay test. Okay, it looks like I'm stuck here. This is the point where as a tester, I'm kind of worried. Is there something wrong with the application? Okay, well, it looks like my Selenium test failed against the new version of the application. Unfortunately, it's not immediately clear to me whether this is a regression or whether there is something that's changed on the website to make my test not work in the way that I expected. And this is a place that we've all been. Now, the good news here is that while the test was executing, Parasoft Selenic was watching. Looking at the console in the bottom right, I can see that Selenic is telling me, well, yeah, you had a failed test. It was due to a bad locator. I'm analyzing the results and creating a report for you. So here's the Parasoft Selenic Analyzer report. It says, yes, you had a test that failed, and it failed due to a bad locator. Okay, now I'm getting some information. The bill pay test failed, and here's a screenshot. Okay, now the reason that I want this is because this would probably happen during my CI execution. And so this would inform me of what was happening in the application. Now, what's really useful is that the report shows me that this test has a recommendation. And here is where we can see Selenic's AI at work. What Selenic has informed me is that the test could not click on payee.phone number, and it believes that we should be able to successfully fix the test if we use one of these recommended locators. Okay, but where did these locators come from? These are generated from the AI. When Selenic found that we couldn't click on this particular element, it went back through time and simulated different executions against the application and constructed a series of locators that would have successfully located this element. Each locator is assigned a confidence factor, which is a combination of its stability, for example, how successful this locator would have been in the past, as well as weight, which is a way to customize the selection of certain locator strategies, such as CSS, text length, XPath, based on your organization's best practice for the application. Additionally, it provides me with all the test details and a stack trace so I can feel confident in applying that to my code. Okay, well, this is great information. I now know that the test failed because it couldn't click on a particular field because something changed in the application. And if I were to say, use this locator, it would be successful. Additionally, you can see these recommendations were provided directly back to the IDE. It shows me that same information, that the bill pay test failed, and it was because it was unable to click on payee phone number. I can click on the Go To action to show me exactly where that element was referenced within my test suite. Now let's go ahead and update the locator. By clicking on Update Locator, the IDE provides us with a list of different locators with their confidence factors. You can then select the one that makes the most sense for your application and make Selenic apply the change directly in the code. I can then rerun this test and it should be successful. So I'm doing a quick validation of that now. So here we see the first test still passes. And here comes the second test that was failing. Great, I have fixed my Selenium test. But wouldn't it be cool if Selenic could self-heal the Selenium test for me at runtime? See, what I did here was I went back and I fixed the test case. And that's good. But in order for that to happen, I had to have a test that failed. And if that had happened during my CI execution, I would have lost valuable time. This is where Selenic's self-healing capability comes in. By simply telling Selenic, hey, try that out for me, Selenic will apply its AI to fix your nightly tests at runtime and prepare the recommendations so you can review them and apply the fix to the Selenium test in the next morning. So I'm going to revert the test back to its original state, and I'm going to run it with self-healing enabled. Now, this would normally be enabled as a part of your CI process rather than in the IDE. But what's going to happen is it's going to go through the execution of the different test cases, and then when it comes to that bad locator, it's going to use the AI constructed locators to automatically swap out a good locator at runtime. Okay, this is going to happen quick. So you can see it is now initiating self-healing in the console in the bottom right-hand corner. It's trying different locators. It gets a good one, and the test proceeds. The test is successful, and the CI process wasn't blocked because of automatic self-healing. Now let's look at the new report. We see it looks a little different. It says no tests failed, but you have a test that you need to fix. It's provided me with information about where that test is, the button that it couldn't click on, and a screenshot, same as before. If I dive into the details, it provides me with a list of locators with additional information that it used this particular locator to heal the test. This helps me validate that this particular locator really works and helps me drill down on this being the one to use going forward. So let's look at the recommendations that were imported into the IDE. Here I see that the test was healed using this particular locator, which makes the decision-making process much easier. Yeah, I feel comfortable with this one. And through this, I can take my existing Selenium tests And by making a simple change to the execution, I get more stability through locator recommendations and self-healing at runtime. But wouldn't it be cool if I was able to get a head start on creating Selenium tests like this from the very beginning? And so this is where the third part of our story comes in, and that is one of creation. So what actually happened in my application, if I go a little deeper, is that I got a new field, email. If I go back to the previous version of my application and log in, I'll see that that's actually the first change that took place between these two versions. But there were also a number of hidden changes in the application under the surface. For example, the ID attribute of phone number is now dynamic, which means it's going to change every time. And that's why it broke. Okay, so what I'd like to do is create a new Selenium test for this workflow. And to do that, I can leverage the Parasoft Recorder in Chrome. The Parasoft Recorder gives me the ability to record UI actions against the application for Parasoft Selenic. And at the same time, I can capture API traffic for creating API tests with Parasoft SOA Test. But we'll save API testing for a later conversation. So let me just get my application into the state that I would like. I'll start recording, and I'll go through my workflow. I'll start by logging in. I'll click on Bill Pay. I'll enter my information, adding an email. I'll go ahead and send the payment and log out. I'll then return to my control panel, stop my recording, and now it's going to prompt me for some information about the test I just recorded. So I'm going to go ahead and call this Parabank New Bill Pay. I'll give it a description, New Bill Pay Flow with Email. I'll associate a requirement to it. Here I'm going to associate the test with a story in Jira, and then I'll download the recording. Now I can either hand this off to another Selenium test creator, or I can use it myself. Well, I'm going to go ahead and use this myself, and I have two options for the test that I create. As you will see, the test that I'm going to create will use the page object model. The page object model is an industry best practice for creating Selenium tests. When creating a Selenium test using the page object model, individual pages are defined as objects, and then elements are added to that page. You will want to interact with these elements in your test scripts, but you don't want to define them every single time you interact with them. By defining them with the pages to which they are associated, you can reduce redundancy in your tests, as well as making maintenance a lot easier, because if you ever have to change that locator, you just change it in one spot and it propagates through the rest of your test suite. Now, if I wanted to, I could add that test right here to my existing Selenium test suite, and it would update the page objects. But I'd like to create a brand new Selenium project from scratch. So I can come in here to our Eclipse project wizard, and as you will see, I have the option to create a Selenium Java project from recording. I'll go ahead and name this Parabank. I can then supply my UI test. You'll see that it provides a name for me. I'll give this a name and then a class, and I'm ready to go. All I have to do is hit finish. You'll see it's constructed some things behind the scenes for me. I have a new Selenium test that has all the necessary framework built, as well as information about my description and the requirements. And the best part is it's built using the page object model, which means this test is going to be easy to maintain over time. I can then go directly to run this test using my Selenic configurations, which makes the process of generating recommendations, taking screenshots, and self-healing very simple, as well as creating API tests, if I so desired. So let's say you have a mature Selenium testing practice, and as a result, you have thousands of test cases. When development releases a new version of the application, it can be difficult to determine which Selenium tests you need to run to validate the changes. This is where Parasoft Selenic's test impact analysis comes in. With test impact analysis, you can understand which code each test case covers. Then, by identifying what's changed in the new application, you can immediately identify the subset of tests that you need to run to validate those changes. So let's go ahead and look at that in action. All of my tests already run during my nightly CI execution. Here is an example against the current version of my application. By simply making a one-line change to that nightly execution, Parasoft Selenic will execute the test cases and gather coverage by monitoring the application at runtime. It will then associate those test cases with the underlying code. See, notice here how I actually executed 2 test cases? That will become important later. When I get a new build, I'll want to only run the subset of test cases required to validate the changes. So you can do that by using test impact analysis. By simply defining where the new binary is located, in this case a WAR file, Parasoft Selenic will be able to identify the differences between the 2 applications and then automatically run the appropriate subset of test cases. So I'm going to go ahead and execute that. Parasoft Selenic is analyzing the differences between the 2 versions of the application, determining which test cases to run, and then only executing the ones required to validate the change. Okay, my test is executing now, and look, it's only one test because that's the only one that was affected by the changes. Oh, so it looks like there was a change in the new application that has broken my test. Not to worry though, let's go ahead and take a look at that report. Parasoft has now provided me with an analyzer report indicating that in the new version of the application, I only needed to run this one test to cover the changes that were made. But in this one particular test, there was a breaking change. It looks like an element locator needs to change. This will be easy because Parasoft Selenic has provided me with AI-powered recommendations I can use to fix the test. Alright, so in this presentation I have shown you the key capabilities of Parasoft Selenic, starting with AI-driven recommendations that help you reduce the time spent maintaining, repairing, and fixing broken tests. Self-healing, to reduce wasted cycles from failed builds due to unstable tests. Page object model-based test creation, where you can record UI interactions to give the team a jump start on creating maintainable tests from the start. And test impact analysis, so you can optimize your test execution for quicker feedback from your CI/CD pipeline. If you're interested in learning more, I invite you to go to parasoft.com/Selenic/try to get a free trial, or email us directly at info@parasoft.com.